Let's evaluate the definite integral from 0 to 1 of x squared times e to the x cubed dx. We need to find the value of this integral using substitution method. The first step is to identify the right substitution that simplifies our integral. If we look carefully, we notice that x squared is related to the derivative of x cubed, which appears in the exponent. The derivative of x cubed with respect to x equals 3x squared. This relationship suggests that u substitution will be the perfect technique for this integral. So let's set u equal to x cubed. Now we need to find du and rewrite our integral in terms of u. Starting with u equals x cubed, we take the derivative to get du over dx equals 3x squared. Therefore, du equals 3x squared dx. Solving for x squared dx, we get x squared dx equals 1/3 du. This transforms our original integral from x squared e to the x cubed dx into 1/3 times the integral of e to the u du. Since this is a definite integral, we must also change the limits from x values to u values. When x equals 0, u equals 0 cubed, which equals 0. When x equals 1, u equals 1 cubed, which equals 1. So our integral becomes 1/3 times the integral from 0 to 1 of e to the u du. Now we can evaluate this much simpler integral. We need to evaluate 1/3 times the integral from 0 to 1 of e to the u du. We know that the antiderivative of e to the u is simply e to the u its. So we get 1/3 times e to the u, evaluated from 0 to 1. Applying the fundamental theorem of calculus, this equals 1/3 times the quantity e to the 1 minus e to the 0. Let's simplify this expression to get our final answer. Since e to the 1 is just e, and e to the 0 equals 1, we get 1/3 times the quantity e minus 1. Distributing the 1/3, our final answer is e minus 1, all over 3. So the value of our integral from 0 to 1 of x squared e to the x cubed dx equals e minus 1 over 3. Let's also find the decimal approximation of our answer. We know that e is approximately 2.71828. So e minus 1 over 3 is approximately 2.71828 minus 1 all over 3. This gives us approximately 1.71828 over 3, which equals approximately 0.5728. Let's review the key steps we used to solve this integral. We recognized that x squared is related to the derivative of x cubed in the exponent. We applied u substitution with u equals x cubed and du equals 3x squared dx. We transformed the limits of integration, which conveniently stayed from 0 to 1. We evaluated the simpler exponential integral to get our final answer of e minus 1 over 3.